classification of the organic compounds, that how we can classify the organic compounds. Basically, in introduction we have two classes of the organic compounds. So mainly the organic compounds have been classified into two types. The first one type we have open chain, or they are also known as acyclic organic compounds. And the second type we have, it is closed chain, closed chain, or known as the cyclic organic compounds. So here we have two classes of organic compounds. The first one we have open chain or acyclic organic compounds, and the second type we have closed chain or the cyclic organic compounds. So let's have a look on the open chain or acyclic organic compounds because it has been classified further. So mainly the open chain or acyclic organic compounds, what does mean by this open chain or acyclic organic compounds? These compounds in which the carbon atoms are in open chain skeleton, in open chain skeleton, or we can say that in open chain structure, and they form the long possible chains, so known as open chain organic compounds, in which the compounds form the open chain or the long possible chains are known as open chain organic compounds. Further, these open chain organic compounds have been divided into two types. So, the open chain organic compounds have been divided into mainly two types. The first type we have straight chain organic compounds, and the second one type we have branched chain organic compounds. So open chain have been divided into two types. The first one we have closed open straight chain, and the second one we have branch chain organic compounds. So let's have a look that what does mean by this straight chain and the branch chain organic compounds. So in the straight chain organic compounds, by definition, the straight chain organic compounds are the compounds in which the carbon atoms link with each other with each other to form a straight chain. Because it has been shown from the straight chain organic compound, it means the carbon atoms are going to link with each other to form the straight chains. So in this straight chain organic compound, they are not gonna to have any branch. They have no branch or sidewise attachment of the carbon atoms, so they have just the straight chain of organic compounds. Likewise, if we have an example of propane, it is known as N-propane, and it is going to show the normal propane. Its molecular formula we have C3H8. So its straight chain or formula we have, or the straight chain structure we have, first CH3, next we have bond with CH2 and bond CH3. So this is the straight chain formula for the propane. And if we have another example like N-butane, then we have its formula like C4H10. So we have CH3, CH2, CH2 and CH4. So this is the straight chain formula for the butane. We have here the prefix N. This prefix N stands for the normal. Stands for the normal, and it is only used for the straight chain organic compounds. Along with the name of the straight chain organic compounds, we will put the letter N, that is going to show the normal chain of that compound. Next, we have the second type of the open chain organic compound. It is the branch chain organic compound. So it is the second type of the open chain organic compounds. In the branch, we just see that the organic compounds or the all carbon atoms are not present in linear sequence. They are not present in the liquid linear sequence, rather they are forming the branched chain structure. The branched chain structure. Now, what does mean by this branch chain structure? There, simple means that at least one carbon atom is linked with more than two carbon atoms. In the simple linear, we have just one carbon atom is bonded to one other one carbon atom, but for the branch and there must be one carbon atom that is gonna to link with the other carbon. So this is gonna to make the branch chain or the side chain structure for the formula. So we have basically the structure for the butane. Butane. Its molecular formula we have C4H10. Next we have its branch chain formula like this CH3, CH3 and the side chain like CH3 and here we have CH. So this is known as isobutane. The prefix iso is going to show for the branch chain organic compounds. So this is the formula for butane. If we have the structure for the pentane, pentane. Pentane means 5 number of carbon atoms, C5, and the hydrogen we have 12. So its formula is CH3C. We have the side chain over there CH3, CH, and we have CH2 and CH3. Here we have total 5 carbon atoms, and this is the branch chain structure for the pentane, and it is known as isopentane. The prefix iso has been added, that is corresponding to the simple alkanes or the branch chain alkanes. So this is the simple branch chain organic compounds in which there is a side chain, or we can say that all the atoms are not present in the linear sequence, rather than they are having the branch chain alkanes. At least one carbon atom is linked with more than two other carbon atoms. So here the one carbon atom it is linked with the two, and the next on it is linked with the three carbon atoms. So this is going to make the branch chain structure of the organic compounds. I hope you guys understand about our today's lecture for the representation of the organic compounds. In the next lecture, we will have the second type, that is closed chain or cyclic organic compounds. And for this lecture, if you have any queries, you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.